What questions do you have?
Number 10 on the homework.
Okay, let me open up the homework.
You're gonna have to wait until I get done with my Zoom lesson.
Okay, here we go. So we've got Epsom salt is used, blah, blah, blah. Determine the mass percent H2O in the hydrate. Why is that 4 like that? I should fix that. Suppose you heat and remove the moles of hydrate, determine the mass remaining. So I'm going to change my share here in just a moment. Okay, I'm going to change my share so you can see what I have written down. And all I've written down here is just some information from the problem. So we have some magnesium sulfate, heptahydrate, and we're supposed to get the mass percent H2O and the mass after heating. So to get mass percent, it's always going to be the mass of the part over the mass of the whole times 100%. That's the definition of mass percent. So in this case, what is the mass of the part? And here, since we're interested in the mass percent H2O, it's going to be the mass of H2O in MgSO4.7H2O. Now, if you had to guess what the whole is, what do you think the whole is?
The whole is the MgSO4.7H2O.
Correct. So let's find some numbers here and let's figure out these things. I know that 1 mole of H2O is 18.02 grams of H2O because each hydrogen is 1.01 and oxygens are 16.00. And so this is one that I've done a number of times. 1 mole of MgSO4 is going to be 24.31 for the magnesium, 32.07 for the sulfur, and for the oxygens, it's going to be 64.00 for a total of 120.38. So I'm going to put 120.38 grams. Now you notice I didn't bother getting the mass of magnesium sulfate heptahydrate because I can do it from these numbers. So here we're going to have 7 times 18.02 grams. Down here, we're going to have 120.38 grams plus 7 times 18.02 grams. What do you think about what we've written there so far?
Yeah, I get it.
Okay, and then times 100%. Now let's multiply some numbers out here. I can estimate these because 7 times 20 is about 140. But this is not 20, so it should be more like 125 for the answer. And I get 126. And since I have 4 significant figures here, I'm putting a little arrow to the 1 there. And then I get divided by, and I'm going to do a little work up here, 120.38 and 126.14. 2 carry the 1, 5, 6, 4, 2. So divided by 246.52. And this is good to there. So I'm going to get 4 significant figures and then times 100. And I get 51.17%. So that's the mass percent H2O. So the kind of work I would expect to see is, write out the formula, show the numbers, and that. Any questions about that?
No, that's good. Thank you.
Let's look at the second part. What is the mass after heating? Okay. Here, if the mass percent of H2O is 51.17%, then that means the mass percent of MgSO4 is 100 minus 51.17%. And that's going to be 48.83%. Any questions about this one right here?
That right there is, it's after, okay, so once it's heated, then it has been dehydrated. Is that
Right.
what we're assuming?
So if we draw out the reaction, we have MgSO4, 7H2O turns into MgSO4 plus 7H2O.
Then the mass of the water would be turned into gas, and all
Right.
that would be left is the MgSO4.
Right, because when we talk about mass percent in each of these cases, the percentages should add up to 100.
Right. Okay. So that's
how I know it's 100 minus 51.17. So here I've got 51.17 for the water, and I've got 48.83 for the MgSO4. Any questions about that?
nope.
So this would be the first thing I do for part B. And the second thing I do for part B is I'd start off with my 1.394 grams of magnesium sulfate heptahydrate. And I'd multiply by this percentage. And here's how you use this percentage and the way I would want to be have you use it. First of all, this means 48.83 grams of MgSO4 in 100 grams of MgSO4 7H2O. That's what 48.3 means. If you had 100 grams, 48.83 would be this stuff. So I can
Right.
use that up here, and I would say 48.83 grams of MgSO4 for 100 grams of MgSO4.7H2O. Now, most people, when they deal with percentages, they just move the decimal over 2 places. And we're not going to do that. We're going to do the real thing you're supposed to do with percentages. And the real thing you're supposed to do is divide by 100. And the reason you're supposed to do that is because that is the definition of percentage. So when we do this work and we estimate it, you can imagine that 48.83 over 100 is about half. Half times this, which is about 1.4, should end up being about 0.7, but probably a little less. And we actually get 4 significant figures.
That last part about dividing by 100.
Yeah.
Can you go over? I mean, I understand that. I understand what we're doing with the
Here's why we
Fi-
divide by 100. 50% is 50 divided by 100.
right. Okay. That's what you're saying now.
62% is 62 divided by 100. And we had 48.83%. So that's 48.83 divided by 100. And because this is percentage, you put part on top and you put whole on the bottom. In our particular case, the 48.83 was magnesium sulfate, and the whole was magnesium sulfate 7H2O. So that's the definition of percentage, is you take the number and divide by 100.
Right.
And if you divide by 100, you're going to move the decimal over 2 places. And that's why your math instructor says, hey, for percentage, just move the decimal over 2 places. But I think that's bad advice, because you don't know why you're moving it over 2 places. You're just saying, hey, move it over 2 places. You're moving it over 2 places because the definition of percentage is out of 100. And I'm 100% right, which means I'm right 100 times out of
100.
100, which means I'm right all the time when it comes to percentage.
As long as you're not saying you're right 100% of the time when it comes to statistics.
No, I'm not. And the reason I insist that people follow my lead here is because if I give you this number, half the people in class will do that. Because I moved the decimal over 2 places, right?
Mm-hmm.
So half the people in class will look at that and go, that is correct. Now, the definition of percentage is you divide by 100. That's the definition of percentage. So here, if I divide this number by 100, does it turn into a bigger number?
It does, right?
I divide a number by 100, does it turn into a bigger number? Any number in the world, I divide by 100.
Oh, right. Bigger? I see what you're saying. It doesn't, yes, it is turning into a bigger number in that moving the decimal place scenario, but it doesn't actually turn into a bigger number.
No.
Yes.
You are moving the decimal over, but that's the real number you're supposed to use.
Mm-hmm.
And people are uncomfortable with making a whole bunch of zeros here, and so they do that because it looks better. Look at it, it looks better, but it's wrong. So if you get 0.000016%, what do you turn that into? You turn it into 0.000016 over 100. Same number over 100, and boom, you're gold. Every time this works. So, what's the answer here going to be?
All right, so we'd finished out. The MgSO4 7H2O would cross out, and then you just divide 48.83 by 100 and multiply it by 1.394.
Yep, and you get point. So this would be the second part of B that you'd want to show. This is the first part. Whoops. This is the first part, and this is the second part. And 4 significant figures because of 4 here, and because percentage is defined as being over 100. How many significant figures in the 100 if it's being defined?
My guess would be 3.
No, infinite.
Infinite.
Yeah, because this is really 100.00000 forever. And those zeros count. So you have 1, 2, 3 plus infinite significant figures, which is infinite.
I had a question on the lab,
Sure.
not the hydrates one, but the naming compounds.
Okay. So let me go to that so I can open it up. And when you find the question, give me a chance to open up the lab, and I can get on the same page as you. Okay, I have it opened up. So what would your question be?
What I'm trying to figure out where I did it.
I bet it's an assignment question.
It had to do with yeah, it was like one of the assignment questions, and it was talking about naming or writing
How about
writing the compound as an anion and a cation.
How about this one? The formula for sodium perchlorate is, does that sound right?
No, it was just when you had to convert it to its cation or its anion form. And I
let me show you the lab itself, and you can tell me whether or not any of these problems seem like it. Like, how about number 1?
I found it. It's number 3.
Okay. So we have that the formula for sodium perchlorate, I'm writing some things down here, and I'll share that with you in just a moment.
Sorry about that confusion.
No worries. And calcium chromate is Cr or CaCrO4. So for each of these, you're supposed to get the cation and the anion. And then finally, you're supposed to get the formula for sodium chromate and calcium perchlorate. So if you look at the last questions, you see how I'm asking you to give me the formula where you switch the ions?
Yeah.
Okay. So I'm going to do a share here where you can see what I'm writing. So you can see the thought process here for this problem.
Okay.
Okay. So we have sodium perchlorate and calcium chromate, and this is what we're given. And we want the ions, first of all, and then we want these. So for sodium perchlorate, we know that that must be the sodium ion, and we know it's a +1 charge because it's in group 1A. Okay? And we know there's only one sodium because there's no 2 after the sodium, or a 3 or a 4. So we know there's only one of them. Now, if this part of the name matches that, that means that this part of the name has to match whatever remains. So what is the perchlorate? It is ClO4. So sodium ion, perchlorate ion. Now, what does the charge on the perchlorate have to be when the whole ionic compound has to be neutral? What does that charge have to be?
Negative.
Precisely. So now we know that the perchlorate ion not only is ClO4, but we know it's a -1.
So the cat ion is sodium and the anion is perchlorate.
Right. Cat is positive and an is negative. And the way to remember that is an or a usually means the opposite, right? So let's see, antithesis starts with an A, antibody, A. Those kind of mean opposites, right? So opposites sound like a negative, so anion, negative. You can't use cat as being positive because some people like cats and some don't.
Sodium is again across the top with the 1A. Those all have a +1 charge, and then 2A has a +2 charge.
That's right.
Okay.
And so if you look at calcium, where is that?
It's in the 2A, so it's.
So I'm going to put an underline here, underline there, and it becomes calcium ion. So
does that mean that the oxygen also carries a positive charge?
No.
Or negative charge?
No. Let's look at the one above. Sodium is the cation, right?
Yes.
Okay. Perchlorate is the anion. There's only one anion, and you've used sodium as the cation, and you have to account for all of the other elements. So the perchlorate must be that. The perchlorate is everything else. So you don't say there's a negative charge on the oxygen. You say there's a negative charge on all of this.
That makes sense. I was just trying to break it down in my head of how that got a negative charge, since calcium has the +2 charge, the calcium ion.
Well, here, we're not going to worry about this. Let's just focus on this guy. This whole thing has a -1 charge, the whole thing.
Right.
So
we don't want to think about breaking it up. We just want to consider it as the perchlorate ion is that it's.
Yeah, because if we do break it up, this is what we'd break it up into: a chloride and 4 oxides, right?
Mm-hmm.
And
yeah,
if
that
you
seems
look
way
at
too
that,
much.
that adds up to -9. But this says -1, and this is correct. So what? And this is not correct. If this is not correct and it's based on this, what does it mean about this?
That's inaccurate.
Yeah. Really what's happening here is you have a chlorine and you have 4 oxygen atoms attached to it like this. And the whole thing is stuck together and it's got a -1 charge on it. And the reason it has a -1 charge on it is because it's got one more electron than it has protons. So the chlorine has 17 protons. The oxygens have 8. So 8 times 4 is 32, 17, 9, 49. So all of these together has 49 protons. How many electrons does this sucker have?
You said one less, 48?
Well, look at the charge. Does the negative charge mean more protons or more?
No, it means
electrons?
more electrons, so 50.
So 50.
One more. Okay, yeah, that makes sense because the electrons carry the negative charge.
Correct. So that's how you figure out how many electrons an ion has, is count the protons and then compare the two. If it's a negative charge, it's got more electrons, add electrons. If it's got a positive charge, you got to take away electrons.
Right. And it's electrons that you're moving around. You're not adding protons.
Right. Well, if we added protons, then that means one of these oxygens would have to have 9 protons, which means it's fluorine now. Or if you take away protons, you take away 1 proton from 1 oxygen, now you have 7, and now it's nitrogen. So then you think, okay, well, we'll take it away from chlorine. You take it away from chlorine, and now it's not chlorine anymore. It's sulfur. So you're always moving electrons around. That's chemistry.
All right.
Okay, so what does the formula for chromate have to be based on what we've learned here?
What does the formula for chromate?
Yeah.
I wrote CrO4.
That's a good start. What's the charge on it? Well, let me ask you this first. How many chromates do you see here?
Oh, okay. There's 1 chromate.
Good. How many calciums do you see there?
1 calcium.
So based on the charges have to add up to 0, what does the charge on your chromate ion have to be?
-2.
Correct.
Okay.
So if we know sodium is +1, and we know chromate is CrO4 -2, how do we get the formula of that compound?
Just put them together.
Switch and simplify.
Okay. I remember you saying that before.
Okay, so what do I
So
mean
you're
by
going to switch the you're switching the what are you switching?
The charge becomes how many of the other.
You're switching charges.
So the charge becomes how many of the other.
How many of the other?
So if
So
I have a
2,
charge of 2 negative,
so it's
I
going
have
to be
2 sodiums.
yeah, okay.
How many chromates do we have?
1.
Okay, so if we've done this correctly, this should be neutral. Let's check and see if it is. So how can we check on this? And the answer is this Na2 means you got 1 sodium ion and another one. Here you've got one of these with a -2 charge. Does this all add up to 0 charge?
Yes.
So we've done it right. So I want you to use this information up here, and I want you to get the formula for calcium perchlorate. Do it the same way we did here, where you write the ions out, then switch and simplify, okay?
Okay.
I'm going to be honest with you. I usually put a question like this on the test. You should know this stuff. So it's good that you've asked about this, and it's good that you're practicing.
CaClO6.
No, I see what you did there, but let me show you. So do you see how we have this with a +2 charge and this with a -1 charge?
Yeah.
So we're going to say Ca, only one of them, and then ClO4. But I want two of these.
ClO8.
Nope. So I want two of these. And if I write ClO8,
Oh,
that
it's two.
means 8 oxygens and only 1 chlorine. So here's the trick.
The 2 in front of the Cl.
Nope, parentheses.
The parentheses. Okay.
So what does this mean? This means 1 calcium and 2 of what's inside the parentheses. That's what that means.
That makes sense.
And we know these are +2. So what does that mean that each of these has to be?
-1.
Correct. So that's how we deal with these things called polyatomic ions. If there's more than one of them, use parentheses and a subscript. So you have a bit of trouble with that. So I'm going to give you another problem where you have to come up with the correct formula using the subscript, okay?
Okay.
Here's the 2 ions where I'd like you to write out the formula for the compound, okay?
Okay. Al2 parentheses HPO4 parentheses 3.
Perfect. You want to try another one?
Yeah. So SN2 parentheses SO4 parentheses 4.
Like that?
Yes.
Well, you certainly deserve partial credit for that, but it's not correct. You switched. Did you simplify?
No.
What factors
So
into a
S
2 and a 4?
a 2.
So we'll divide each of those by 2.
Just SN parentheses SO4 parentheses 2.
Correct.
Okay.
You got it. How about this one?
Parentheses NH4 parentheses 2 SO4.
Correct. Good job.
And it can't be simplified, right?
Well, I mean,
Yeah, I
there
was
is
thinking about that, but
there's a 2 and a 4 here, but you're not allowed to simplify one part of a polyatomic ion.
yeah, then you're changing it. You're taking,
Yeah, you're changing
you're
it to
saying
SO2 and it's not the same.
right.
Good job.
Thank you.
Yeah. What
I
else
did
can I
have
help
one
you
more
with?
one more question. Number 4 on the lab. The next question, the nitrate ion.
Okay, I'm going to take a look at question number 4. The nitrate ion is NO3 -1.
Mm-hmm.
How many electrons does it have?
I put 31.
Well, how many protons does nitrogen have?
Nitrogen has 7.
Good. How many does each oxygen have?
8.
Let's add them all up together. What do you get?
31.
31. It's got 31 protons. If this were neutral, how many electrons would it have?
31.
31.
But
But it's not neutral.
It's negative. So that means
So does it have more electrons or more protons?
has more electrons.
So we better
Has
say it's got 32 electrons.
32.
So I'm going to write negative. So more electrons. Fair enough?
Yes.
Now, what if it was made out of this? What would be the formula of this thing if we put it all together? NO3.
NO3 positive? Is all negatives?
Yeah, those are all negatives. So what's -2, -2, -2, and -3 added up together?
-9.
Yeah.
So it
And we
just
know this is wrong. So if that's wrong, what does it mean about this over here?
that's
This
also
is
wrong.
wrong. So this is wrong. So we can say that the nitrate ion is not made up of little individual ions itself because it doesn't work out. And this ion is actually a nitrogen attached to 3 oxygens like that. And the whole thing has a negative charge.
Are you talking about the last part, the nitrite as or I'm sorry, the second part. Yeah, the question was, how do you know that it's not correct?
Yeah. And the answer is because the charges don't add up.
Okay.
It's that simple, but it's also that difficult.
I thought it had something to do with the wording also, how it was. No, it's just charges.
Yeah. Just because the charges don't work out. We know it's only got 32 electrons. How many electrons does this guy have? The answer is 40. Because this guy still has 31 protons.
Oh, but he's got
How do you get a -9 charge? You got to add
extra,
9 electrons
or
to that.
nine more electrons.
So this has 40 electrons, which is no way. I don't know of anything that has a -9 charge, I'll be honest with you.
Well, you said chemistry was all about moving around electrons, so this is just a generous chemist.
No. Well, see, we get to move around electrons, but we
The
have
right
to
way.
keep track of them. We don't get to just bring electrons in out of anywhere. That's magic. And chemistry, there's no magic. We always make sense of it. And
A
if we
mass
can't make
spectrometer
sense
kind
of
of
it,
seems
we
like
try to. What's that?
said mass spectrometer seems kind of like magic.
It's not. It's really cool science.
It's interesting. It's definitely making my brain flex in new ways.
Yeah, what I taught you about mass spectrometry is the tip of the spear. It's not all of it. I mean, you can actually, for proteins, you can sequence proteins and find out what is the order of the amino acids in the protein. You can do all sorts of different things with mass spectrometry.
Wow.
And it's pretty cool stuff.
So it is magic.
No, we'll call it sophisticated beyond the scope of most people to understand. So it appears to be magic.
That's
Kind of like
all.
all those magicians on TV.
Yeah.
They're not doing magic. They're just tricking you.
What about Santa Claus?
He's not a magician.
Yeah, that's all the questions that I had
Okay.
for you.
Well, then we're done.
I appreciate the help, and thank you.
All right.
All right. Take care.
Catch you later. Have a good one.
You too. Bye.